So we're still working on Unit 5-6 here, proportional reasoning. In the last lesson, we talked about percents, fraction, and decimals. So this lesson is going to focus on the last bit of material in this learning guide. We're going to look at some stuff out of 6C here, scale diagrams. So let's just jump to these couple of questions that we have here. So scale diagrams. Scale is a very specific kind of ratio. The scale of a diagram compares the size of something in the diagram to its actual size, or its size in real life. And it's always written as a ratio with the numbers in the same order. So you get a ratio of the diagram measurement first, so how big the thing is in the diagram, to the actual measurement, how big it is in real life. I'll just put real life down in here. Okay. So here's an example. A stop sign has an actual width of 60 centimeters, so that would be in real life. This picture of a stop sign is 6 centimeters wide. So if we were to measure this little picture here, we would measure it to be 6 centimeters across. What is the scale of the picture? Well, we want to set up a ratio. We want to set up the ratio of the diagram measurement to the actual measurement. So in this case, we're trying to find the scale. So they give us both of the numbers. They give us the diagram measurement, which is 6 centimeters, and they give us the real life measurement, which is 60 centimeters. Okay. Now we've got a ratio there, and this works okay because we've got centimeters here and we've got centimeters here. Okay. So those units have to agree, so we're okay there. Now when they give you the scale, one of the numbers in the scale is always going to be 1. So we want to get one of these numbers to be 1. One number should be 1. So what we're going to do is we're going to look for our smallest number. Okay, our smallest number here is the 6. It's much smaller than the 60. And we are going to divide by 6. Okay, so we're going to say divide by smallest number. Because if I do 6 divided by 6, I'm just going to get 1. But if I divide by 6 on one side of my ratio, I have to also divide by 6 on the other side to get an equivalent ratio. So 60 divided by 6 is 10. So the scale of our diagram is 1 to 10. So that's how you find the scale of a picture, given the measurements. The other kind of question you might be given is one like this. We're told that this diagram of a bug has a scale of 3 to 1. So we're given the scale here. How large is the bug in real life? We're given the scale, we want to find either the real life size or the diagram size. So let's say we measured this diagram here. We found that in the diagram, the bug is 5 centimeters tall. We want to set up, we're going to want to set up a proportion here. So what they give us is they give us this ratio, scale. Let's write this ratio in words just like we would in any other kind of a proportion question. So scale is always the ratio diagram to actual. And I'll write this ratio as a fraction here. Well, in this 3 to 1 that they give us, the 3 represents the diagram, so I put it on top. The 1 represents the actual, so I put it down on the bottom. And I want to set up a second fraction that is going to be equivalent to this one. So now I have to look at what I'm given in the question and what I'm being asked to find. I've got this 5 centimeters over here. And I ask myself, does it represent a size in the diagram or an actual size? Well, because we measured it on the diagram, it's a diagram size. So I'm going to put it up here in the numerator where all of my diagram measurements are. What am I being asked to find in the question? I'm asked for how large the bug is in real life. So I'm being asked for the actual size of the bug. So I need a variable down here. And now I just need to solve this proportion for x. I'm going to cross multiply, and I get 3x equals 5 centimeters. And then I'm going to divide by 3 on both sides, and I'll get x equals, if I do 5 divided by 3 on my calculator, I get 1.67, and that's going to be in centimeters. So in real life, the bug would be 1.67 centimeters tall. So this picture shows the bug larger than it would be in real life. So this diagram here is what we call an enlargement, because we've made the bug bigger in the diagram. So we'll say diagram is an enlargement. If we were making the bug smaller in the diagram, we would have called it a reduction. So we'll just say reduction makes the object smaller in the diagram. And let's make sure we spell diagram correctly here. And those are scale diagrams.